Let's talk about two different ways we have of measuring the size of an earthquake. One way to measure the size of an earthquake is by its intensity. And the intensity is just how we respond, how objects and we as people respond to earthquakes. It's the degree of shaking based on behavior and the damage that we're able to see. And for intensity, there's a scale that we use, which is called the Modified Mercalli Intensity Scale. The other way that we can measure the size of an earthquake, which is more often reported in the news, is by the magnitude of the earthquake. And the magnitude is the amount of energy released. And we measure this on the Richter scale. Let's start with intensity. Here's an example of two different earthquakes, historic earthquakes that happened in the United States. The New Madrid earthquake in 1811 that happened in modern-day Missouri, and the Great San Francisco earthquake of 1906. One way that we can measure how intense this is, and we don't even need seismographs to do this, is we can just look at what was damaged and how people responded to the earthquake. For example, in this first zone here, 3 to 5, this earthquake, even this far states away from where the earthquake occurred, it was felt noticeably indoors, especially on upper floors of buildings because the buildings tend to sway. And then as you can see, as we move closer and closer to the epicenter of this earthquake, we get all the way up to a Roman numeral 7 here, which would be everyone runs outdoors. So as we'll see, at first things kind of are falling off shelves, and then when buildings start to move, people tend to run outdoors. Same with the San Francisco earthquake over here. We can see that the same sort of pattern of less and less response as we move away from it, but people were still feeling it in Nevada and almost up on the Oregon border. There was still some response to that. So this is what the Modified Mercalli Intensity Scale is based on, Roman numerals 1 through 12. And it can just be done by seeing, once again, what the damage was from an earthquake and how people responded to the earthquake. The way that earthquake is typically reported, because it has to do with how much energy was released, is on the Richter magnitude scale. And this is reported, it's a logarithmic scale, which means that a 8.0 earthquake is about 10 times worse than, or has 10 times more energy released than a 7.0 earthquake. But we can see also that we don't have as many of the big earthquakes. Most of the earthquakes that occur are below 2.0 magnitude. So not much energy is released. They're generally not felt, but they are recorded by our seismographs. We don't even get into earthquakes people feel till we get up to 3.0 to 3.9. Once we're above 5, we can start getting some damaging shocks. And then once we're at 6 and above, we can get some very catastrophic earthquakes. The good news is, right, the number of these goes down. We only get about 18 events per year that are in the 7.0 to 7.9 range. But that still is a significant number and can cause a lot of damage and death. So once again, this is on a logarithmic scale. So here is energy here, a measurement of energy, and we can see it's 10 to the 4th, 10 to the 5th. So each one of these would be like adding another 0 to a big number. So we're going up on a logarithmic scale here. And then the magnitude of these earthquakes, we can see when we plot these on a logarithmic scale, they pretty much follow a straight line. So here's some earthquakes from California here, Loma Prieta and Northridge, the San Francisco earthquake. Mexico City had a big earthquake in 1986. And some of these earthquakes do release more energy than a straight linear line. But in general, the amount of energy released relates to a straight line on a logarithmic scale when we compare the Richter magnitude to the energy that's released by the earthquake. And just to give an idea, at first only seismographs can feel the energy between 1 and 2. Then things in people's house start shaking or falling off the shelves. Then entire structures start shaking. And then when we get into these major ones, that's where entire structures become damaged.